Wino countdown. Are you recording? It says it's recording. Okay. So we've talked about derived units like watts and liters. We're talking now about other base units, and there are only 5 you need to know for this class. Does somebody have another one? Yes? What? Kelvin, temperature. So the base unit of temperature is Kelvin, and it's capitalized because it's someone's name. Kilogram probably is not capitalized. I probably accidentally wrote it that way. Kelvin is capitalized, and it is a capital K. There is no degree sign on Kelvin because it's an absolute temperature scale as opposed to a relative temperature scale like Celsius and Fahrenheit. But we still will use Celsius all the time. Yeah, and like Canada uses Celsius, and Great Britain uses Celsius, and most of the countries in the world use Celsius. But the base unit is Kelvin, and the reason for that is 0 Kelvin is the lowest temperature you can go to. There aren't any negative degrees Kelvin, and because negative temperatures cause confusion when you're calculating with them. Okay, we've got 2, 3 more to go. Can you give me another base unit? Meters? Did I hear meters? So length. Length is measured in meters. And of course that's abbreviated with a little m. And we've used the meter stick in here to talk about the precision of an instrument. And so you guys have a pretty good idea of what a meter is. Some people make the joke that the company that makes yardsticks won't be making them any longer. And I beg to differ because they're going to be making meter sticks, and meter sticks are about 3 inches longer. So, anybody have another one? We've got, yes? Time. Time keeps on slipping, slipping, slipping into the future. So time, and the base unit of time is the second. And that's just abbreviated with an S, like it looks like. Okay? One more. The mole. Is that what you said? Yes, I'm sure that's what you said. And that is a measure of amount, like number of things. Number of things. The mole. Yes, and mole is just like it sounds, like the little animal or the spot on your chin that you got to shave around, or it's not pronounced like mole, so it's not a food, and it has an abbreviation. You know what the abbreviation is? MOL. Yeah, that saves you a lot of time. You're going to be using this unit a lot this year. So those are the 5 base units. So we're going to move right down the page because I see here we have prefixes. Now there are a lot of prefixes, like Google is a prefix for a number of things. And I don't use it enough to remember. Is Google 10 to the 100th? 10 to the 100th? Okay, thanks. I see nodding out there. There are a lot of prefixes that chemists use all the time. The only 4 that you need for this class are the ones listed on your paper. And kilo, for example, someone might write kilometer, right? And a kilometer is less than a mile. It's 1,000 meters. So kilo means 1,000. Now we should be able to write that in scientific notation as well. It's 1 times 10 to the third. I'm just going to write 10 to the third. So that's a kilo. So that's kind of a big amount. Centi, like centimeter, is the place you see this most often. Other than, what do you call 1/100th of a dollar? What's 1/100th of a dollar? Yeah, a cent. So you have grown up using the concept of centi. Centi means 1/100th. And if you're going to write that in scientific notation, that's 10 to the negative 2. Milli, of course, is even smaller. And an example would be millimeter. And you know, there are 1,000 of those in a meter. So a single millimeter is 10 to the 1,000th. 1 divided by 1,000. And that is 10 to what power? Yep, negative 3. And nano. Nano is, we're getting down here to like the wavelength of light. It is a tiny measurement if you're talking about meters. It is 1 billionth. There's 1 millionth. Here's 1 billionth. Okay. So it's 1 billionth. And that's where it really gets easier to write in scientific notation. 1 times 10 to the negative 9. Okay. So those are the SI things you need to know. And we're going to practice using these a bit. Some of it I make the incorrect assumption that you've already used these in your past, maybe in the 7th or 8th grade or 6th grade. But if you don't remember doing that, it's okay. We'll get you caught up. Now, I am going to move not to this box. We're going to come back and talk about this box. I'm going to move to the word conversion factor for a moment. So what are conversion factors? You may have read about these, but conversion factors, I'm just going to switch to a new color because I get bored of the same color all the time. There we go. So conversion factors are a way to compare two things that are equal. So that's what they're used for. Did I spell comparison correctly? Comparison of two things that are equal. Now, what do I mean? Well, let me write it here. Are equal. Now, let's think about some things that are common that you know about that are equal. I'm going to do one in the English system of measurement. I'm going to do a couple in the SI system of measurement. So 1 foot is equal to how many inches? 12 inches. So a conversion factor is the comparison of two things that are equal. So 1 foot is equal to 12 inches. In the SI system, we might say that 1 kilometer is equal to 1,000 meters. We're comparing two things that are equal. We might also say that 1 mole is equal to 6.022 times 10 raised to the 23rd power atoms. So 1 mole of atoms is equal to 6.022 times 10 to the 23rd. So a conversion factor is just two numbers combined with units where those things are equal to each other. I hope that helps. I hope that makes sense. Now, you also read about dimensional analysis. And dimensional analysis is always about using units to convert from one thing to another. Using units to convert from, and I'm going to choose a better word here than thing, one measurement to another. And you do these all the time, but you may not have thought of them as a way of converting units. Like you'd say, oh, that's 100 feet. That equals about 33 yards, 33.33 or whatever it is. No, 100 feet, 33.33 yards. So you're converting from one measurement to another, but those measurements are still staying equal. So we're going to spend the biggest thing we do in this class to get you ready for your next level of chemistry is dimensional analysis. We do this all the time. Every test you take from me this year will have dimensional analysis problems on the test. Every single test will have dimensional analysis. So don't forget that. Now, I am going to, before we go on to examples of dimensional analysis, I'm going to come back and look at this box for a moment. Because this box is about how you get scored. Like if we have a test and it has a dimensional analysis problem on it, how do you get all the points? There are always 5 points for this kind of problem. How do you get all the points? Well, it really comes down to, if you're going to do math, you have to show math, not magic. You can't just magically come up with an answer without showing how you got that answer. And showing the answer looks like this. You're going to show these things. You're going to show data. You're going to show units. You're going to show the mathematical relationship, which is the dimensional analysis and the conversion factors that we were just looking at. Substitution and solution. So that's 5 things. So when we're doing these kind of problems, you get 1 point for identifying what is known in the problem. I'm going to switch to red here for a moment. What is known in the problem and what is unknown. When you identify that, that earns you 1 of the 5 points. So showing your work, and the reason for this, there is a reason that I require this, because there is always a certain group of students who don't know where to start the problem. And if you write these things down, or at least identify them by initials, known and unknown, you will know where to start the problem. Guaranteed you will know where to start the problem. I'm going to show you that in a moment. Then, you're going to need to show the units at each conversion factor. Doing the units throughout the problem earns you a 2nd point. Now those units have to be in the right place, the right placement of those units, the right unit to start, and the right unit at the end. So showing all of those units will earn you that point. Then there's another thing here, and that is putting the units in the right relationship with the right conversion factor. So the units correct relationship so they cancel each other in the conversion factor. We're going to look at this in some examples, but that earns you a third point. I hate it when my computer just decides to glitch and go to a different size like that. No, stop, computer. The fourth point is for substituting in the correct numerical value into the conversion factor. And the last point is to calculate the correct answer. So the good news here is if you miscalculate an answer, something goes wrong when you're putting the buttons in, you get in a really big hurry, you can still get 4 out of 5 points for showing your work, even though the answer may be not the right answer. So we're going to look at this, and then I'm going to let you're going to have questions, but we're going to get this figured out for you. All of you will, guaranteed, before the end of this class, you will look at dimensional analysis and say, this is my friend. I'm going to go back to the very beginning slide for this morning, if I can find it, because this is a common technique in physics classes. The common technique is illustrated by SpongeBob here. Old reliable SpongeBob. Don't know what that is. Oh, it's going to suddenly put my picture in. Old reliable is dimensional analysis. When you have no idea what formula to use, if you know the units of your answer, you can always figure out the answer by making the units conform to the units of that answer. And that will tell you how to do whatever kind of physics math problem you might encounter. And the physics equations that you see around the room, it appears there are 11 of them. All of those, or anything more complicated, if you know the final unit you're looking for, you don't even have to worry about an equation. You can just take the numbers that go with the right units and put them together to make you get the final unit, and there it is. Wow, my picture, is it going to go away when I go back to... There it is, it's gone. You can't even tell that I'm doing this the last week before winter break. So, let's look at some examples of conversion factors and dimensional analysis. And so, please be sure you use all the things that I'm showing you here, because this is how you get all the points on your problem. Because for this first problem, you'd be able to just put the numbers into the calculator and out you would come with the right answer. But we need to show how the math works. And so this says how many seconds. Now what I'm going to do is underline that and say this is the unknown. This is what I'm looking for. I am looking for, at the end of this question, how many seconds? And the thing I know in this problem that I'm starting with is a single day. How many seconds in a day? So I'm going to start with the unit 1 day. you always start with the measurement that is the known measurement in the problem. That's what you're always going to be starting with. Then, you're going to use a series of conversion factors to change that. Now, I'm going to use a line like this and lines like this. And everything upstairs in the numerator, we're going to multiply. And everything down below, of course, we're just going to divide. So, I want day to cancel. So I'm going to put day, if I can spell day, D-A-Y, day, here, because they will factor to 1, and I can just cancel them and drop them out of the equation. So they factor to 1, that's why I'm canceling them out here. And I'm going to say there are 24 hours in one day. Then I want to get to seconds eventually, but I don't know how many seconds are in a day, so I'm going to use a second conversion factor here to get me from hours to minutes. And I want the unit here to cancel with the unit down here. So I'm going to make them the same. So, oops, 1 day is 24 hours was my first conversion factor. I'm going to put 1 of the bigger measurement. So 1 hour. 1 hour is how many minutes? 60. Speaking of minutes, that's not for today, is it? No. Or is that the lunch bell? No. That's first lunch, and I know a couple people have to leave here during the period. Just go grab this video. It's such exciting viewing. So, now our dimensional analysis has us converted to minutes. So if we put these things into our calculator now, always multiplying the thing on top and dividing by the thing on the bottom, we would be in minutes at this point. But we want to do one more because we want to be in seconds at the end of this problem. So I'm going to put minutes down here because we want this unit and this unit to cancel out. And I do happen to know how many seconds are in 1 minute, right? So 1 minute is 60 seconds. So I've shown all the work I need to show. I've got all the dimensional analysis set up. I get my calculator and I just do 1 day times 24 hours divided by 1 day times 60 minutes divided by 1 hour times 60 seconds divided by 1 minute. And you're welcome to go get a calculator. I'm going to give us a break in a moment to make sure we can get a calculator if you don't have one. But you're welcome just to get up and walk over here and get a calculator if you want one. Because calculating this develops kind of a muscle memory of what you need to do to solve the problem. So remember, we just multiply by what's on the top and divide by what's on the bottom. Always doing that. And we should come out with your calculator, maybe in scientific notation, it might say 8.64 times 10 to the fourth. That's what I have written in my notes. I didn't actually calculate it just now. But that's 3 significant digits. That's 3 significant digits. We learned we should probably round that to the same as the original measurement of 1 day. So I'm just going to round that to 9 times 10 to the 4. Or it's also okay for you to write that as 90,000 seconds. 90,000 seconds. That is 1 sig fig. So that is how we do dimensional analysis. So I would like to do these other examples as well. I've got to rearrange things on my paper a tiny bit to make sure I have enough room. Kind of made the equal sign look funny. Okay. Show how to convert 56 centimeters to meters. And so this is going to be the easiest way to get used to doing this. So here is what we are. I'm going to do this whole problem, I think, in red. Did I do okay?
You crossed out a day on show how to convert.
And it says show how to convert, but that day,
It's covering 4 point. It's covering 4. After convert on number 2.
Oh, on number 2. So the y is in the way. Is that better? There we go. Thank you. Show how to convert 4.56 centimeters to meters. So this is the thing. I'm going to get just a little bit smaller pen so I can control this better. So this is the thing we know. And this, no, wait, that's the thing we're looking for. How many meters? The unknown. This is the thing we know. Okay. Once we figure that out, we know where to start the problem. We start the problem with the thing we know, 4.56 centimeters. That's what we know. Now I'm going to put in my dimensional analysis, railroad tracks, or people call these various different things. And I want my centimeters here so that they cancel the centimeters here. And I want my final unit to be in meters. Now there's 2 ways you can put this in to your calculation. You want to figure out what is a conversion factor. I always like to use one of the bigger thing is a lot of the littler thing. In other words, 1 meter is 100 centimeters. Now, if you're looking these up online, you might find people doing it with slightly different numbers. Like they could use 0.001 over, 0.01 over 1. I just think it's easier to picture to use one of the big thing and more of the smaller thing, the smaller measurement. So, in this case, just like always, we're going to multiply by the things on the top and divide by the things on the bottom. So this becomes 4.56. I'm going to put it into my calculator just to give myself the same amount of time you're using. 4.56 times 1 divided by 100 equals, and that is, my answer is coming out in scientific notation. I'm going to just change that. There we go. 0.05, oops, 456, and the unit that is left over is meters. So now I know that 4.56 centimeters is 0.0456 meters. And you'll notice our original measurement had 3 sig figs, and our final measurement has 3 sig figs. So we're just going to leave it like that. It is okay if you put it in scientific notation, but you do not have to. You could put it as 4.56 times 10 to the negative 2. Don't forget your unit, because that unit there is necessary to get all 5 of your points. So I'm just going to zoom here and pause so that if you're watching this video, you have a moment to capture all of it in your screen at the same time. We're going to do one more problem, and then I'll pause the video, and there are people here in the room just going, I can do this. I want to get to the worksheet. So we're going to give them the chance to do that. I'm going to switch to a nice dark color here. So here is the thing. Thanks, computer. Thanks a lot. Here's the thing we know. Here is the thing we're looking for. Shazbot, that's all I can say about my computer. Okay. It's not liking my palm recognition. Okay. No, it's not even that. I didn't touch a thing. I'm going to fire my computer. So, thanks, computer. I'm going to do it over here. Show how to convert 1,400 milliliters . 1,400 milliliters. That's the thing we know. So that's what we're going to start with. And we want to convert that to liters. So the unknown, the thing we're looking for at the end, is going to be liters. So I'm going to put my tracks like this, where I multiply everything on the top and divide by everything on the bottom. And my conversion factor, I want milliliters down here so that they will cancel. I want my new unit to be liters. So what this does for you is a lot of people who are working with conversions and they're not super familiar with this, haven't practiced it hundreds of times, they're going, do I multiply or divide? What do I do? And this really helps you overcome that problem, because now we're going to put one big thing. A liter is a lot of little things, 1,000 milliliters. And the milliliters cancel, so my final unit is liters. That's the only thing left in my units right here. So 1,400, I put that into my calculator. I divide by 1,000 and I get 1. I get 1. It'll start writing eventually. I get 1.4. 1. Have I said 1 before? Computer, type 1.4. I don't know. I may have to buy a new stylus. I've been getting more and more difficulty with this. Either that or I need to reboot the computer. 1,400 divided by 1,000 1.4 liters. We have two significant digits in our original measurement. We have two significant digits in our final answer. So I hope that helps you understand how to do dimensional analysis. I'm going to go stop this recording while my computer is still somewhat happy with me.